Let's talk about the intermediate value theorem. Pretty cool theorem. It's almost like one of those things that, oh, I'm glad someone put this to words. It seems like it should make sense. Let f be a polynomial function. The intermediate value theorem states that if f of a and f of b have opposite signs, but one's positive, one's negative, then there exists at least one value c between a and b for which f of c is 0. So just imagine like they get a nice little graphic here. F of b is positive, f of a is negative. There must be some place that crosses the x-axis is what it's saying, and that'd be at c. So in example 12, show that the function f of x equals x cubed minus 5x squared plus 3x plus 6 has at least two real zeros between 1 and 4. So what is f of 1? Find that. That's going to be 1 cubed minus 5 times 1 squared plus 3 times 1 plus 6. That's 1 minus 5 is negative 4 plus 3 is negative 1 plus 6 is, what did I say? So it's 1 minus negative 4, negative 1 plus, so 5. And hey, I got my calculators charged. Yay. So the next one I'll just do in the calculator. But it's f of 4 equals 4 cubed minus 5 times 4 squared plus 3 times 4 plus 6. Let's see what that would be. So it's going to be 4 to the third power minus 5 times 4 squared plus 3 times 4, which is 12, plus 6. So that's 2. So what this is saying, this isn't actually quite how it's supposed to work. We don't know that it actually has any zeros between 1 and 4. So the fact that they're the same sign, that means that it could have between 1 and 4, could have been up here, cross, well, it was positive at 1, positive 4. So if it went down, it had to come back up again, is what we're saying. But for all we know is it just did this. You know, here's here to here. It could have just done something like this. So this one wasn't such a telltale sign. Usually we use this to find a single value. This was an example from the book, so I wanted to use that one. But we have another example coming up. Okay, I guess actually what we could also look at is what is f of 2 and what is f of 3. And if I put this in the calculator, f of 2 comes out to be 0. That's actually a 0. And f of 3 comes out to be negative 3. So it must be something like this, where maybe here's 2 and here's 3. So where you get negative 3. So by checking more values, which is what I should have done, it gives us the fact that it goes positive, negative, then positive, so it must cross twice. So there you go. Okay. They took it to the next level. I didn't think they'd do that. Let's go on to, I guess, is there another one? Oh, I guess there isn't one. Factored form of polynomials. If a polynomial of lowest degree p has horizontal intercepts at x equals x1, 2 through n, xn, then the polynomial can be written in factored form. F of x equals a times x minus 1 to the p1 times x minus x2 to the p2 dot 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 x minus xn to the pn, where the power is pi, I being the index 1, 2 through n. On each factor can be determined by the behavior of the graph at the corresponding intercept. And this stretch factor a can be determined given a value of the function other than the x-intercepts. So how to write formula for the graph of a polynomial. Identify the x-intercepts of the graph, define the factors of the polynomial, Examine the behavior of the graph at the x-intercepts to determine the multiplicity of each factor. Find the polynomial of least degree containing the factors found in the previous step and use any other point on the graph. Y-intercept may be easiest to determine the stretch factor. So let's look at this one here. So we see it has an intercept here, intercept there, intercept here. So we know it touches and goes back here. So that's, let's say, multiplicity 2. So we have x minus -3 times x minus 2 squared times x minus 5. We have an a out front. So p of x equals a times x plus 3 times, and I know the x minus 2 squared is x squared, minus 4x plus 4, just FOIL it out if you need to, times x minus 5. So p of x equals a times x plus 3 times x minus 5 is x squared minus 2x minus 15 times x squared minus 4x plus 4. Do they want this in factored form? I guess that's the big question. And they leave it in factored form, so I'm doing a lot more work than we need to. So, so we can ignore some of this. Let's go ahead and rewrite it. Erase. Okay, I've hit erase. There we go. So let's rewrite this, leave it in factor form. I'm used to teaching this where I make my students write it all the way out. So a times x plus 3 times x minus 2 squared times x minus 5. Okay, now what we have is an intercept at -2. So p of 0 is a times 0 plus 3 times 0 minus 2 squared times 0 minus 5. And that's going to be equal to -2. Because it goes through 0 and -2. So that'll help us find the a. So that's a times, that's 3 times 4, -2 squared is 4, times -5. So 3 times 4 is 12 times -5 is -60 equals -2. So a equals -2 over -60, which is 1 over 30. So our polynomial p of x is 1 over 30 times x plus 3 times x minus 2 squared times x minus 5. There you go.